All right, guys, so we are going to talk about powers of 10. So when we talked about exponents last class, we said there was a base, which is that big number, kind of like the 10 here, and an exponent, which is like the 5. Okay, so we said there was a base and we were raising to an exponent. In powers of 10, all of our bases are going to be 10, as you can see. Remember, there are 3 types of form: exponential, so that's where we have the exponent written; expanded, where you see 10 times 10 times 10 times 10 times 10, and then our standard form, which is just what it multiplies out to be. So we're going to go ahead and fill out this chart to look at the patterns that the powers of 10 have. So let's start with, well, we look at 10 to the 5th. It's already done for us. We know that's 10 times 10 times 10 times 10 times 10, which is 100,000. If we did 10 to the 4th, it would be 4 tens, so 10 times 10 times 10. And all we're going to do is we're going to lose 1 0, so that would make it 10,000. Okay, so go ahead and fill in 10 to the 3rd. You know that would be 10 times 10, which would be 1,000. And try to fill in the rest. So you can pause your video and keep going for 10 to the 2nd, 10 to the 1st, and 10 to the 0. So your paper should look like this if we did it correctly. So every time we were just losing a 10, and then we were also losing a 0. So every time I'm doing this, you don't need to write this, but I just want to show you. Every time I'm doing this, losing a 0, I'm just dividing that number by 10. 10,000 divided by 10 is 1,000. 1,000 divided by 10 is 100. And then we just keep going on and on. Now you remember our 0 property of exponents. The 0 property for exponents says that any number to the 0 power is 1. Okay, now we don't really have any more zeros to lose. So that means when we get to the negatives, if you look over, my decimal just keeps moving one place over. So in 1, it was here. Okay, now we don't have any zeros to lose now, so it's going to move 1 time over in front of the decimal. Okay, and then if you look at your expanded product, remember we said when there's a negative exponent, we put the number under 1 and we make the exponent positive. So like 10 to the negative 1 would be 1 over 10 to the 1st power. Another example we talked about was like 3 to the negative 2 would be 1, always 1 on the numerator, over 3 squared, which is 1 over 9. Okay? So we have our expanded product. The fraction is going to be the same thing because 10 to the 1st is just 10, and then our decimal. All right, so looking at our next one, 10 to the negative 2. As our expanded product, we're going to, here's the negative exponent, we're going to put it under 1 and make our exponent positive. Then we would say that would equal 1 over 10, expanded means we write it out, times 10. So what is 10 times 10? 10 times 10 in fraction form would be 1 over 100. And then in decimal form, it's going to be 0 point, and again, you're just continually moving that decimal over. So we had the decimal here, we moved it over once to the 1st power. We're going to move it over twice to get for the 2nd power. There's other things that people remember. Sometimes people say, well, it's a 2, the exponent's a 2, and that 1 is in the 2nd place away from the decimal. Or you could look at it and say, well, the 2 is my exponent, and I have 1 less 0. It really depends on how you want to remember it. So let's take a look at 10 to the negative 3. 10 to the negative 3 would be 1 over 10 to the 3rd power, which we would say equals 1 over 10 times 10 times 10. Okay? So 10 times 10 times 10 is 1,000. So we're going to say that's 1 over 1,000. Okay? Adding a 0 each time under our fraction. Then if we keep going with the pattern, we have 1 0 behind the decimal. For 10 to the negative 3, we need 2 zeros behind the decimal, and then that 1 is in the third place from the decimal, which matches the exponent. So let's try 10 to the negative 4th. We're going to put 10 underneath 1, make our exponent positive. Hopefully you're seeing the pattern here. You're not always going to be provided the entire chart, but there's a distinctive pattern and relationship between all of these numbers. So 1 over 10 times 10 times 10 times 10. And that's going to give me 1 over, this time, the 1,000, it's going to be 10,000. Because 10 to the 4th is 10,000. 10 to the negative 4th is 1 over 10,000. So it's reciprocal. And then my decimal would be 0.00001. So what I want you to do is try 10 to the negative 5th on your own. Pause the video, and then check with my answer once you have your answer written, to see if you're getting the pattern. All right, so hopefully you got the answer that I have below. 1 over 10 to the 5th equals 1 over 10 times 10 times 10 times 10 times 10. 1 over 100,000, and it's 0.00001. So the 1 is in the 1, 2, 3, 4, 5th place away from the decimal, okay? Now if this still is a little unclear, I have a few more hints that if you want to use them. So number 1 says negative exponents for the powers of 10. Okay, so negative exponents right here are used to represent numbers between 0 and 1. We talked about this last class. We said that those numbers are between 0 and 1 are decimals. Okay, so that means that they're very small numbers, but they're positive. Just because it has a negative exponent does not mean it's a negative number. Oh gosh, having some difficulties writing on this, clearly. Okay. The next one says, when changing a number from exponent form to fraction form, put the number under 1 and make the exponent positive. So we practiced this last class as well, but just another reiteration that when it goes under 1, that exponent has to be positive. I don't want to see any negatives. It should be 1 over 10 squared. 1 over 10 to the 8th. What would this one look like? Well, it would be 1 over 10 to the 12th. And then our last one, same exact concept. 1 over 10 to the 17th. And that last one, you can use this method that I'm going to teach you in number 3. You can also, how I was saying, you can look, and it's, if you're doing 10 to the negative 5, that 1 has to be in the 5th decimal place. It matches the exponent. Or you could think it has 4 zeros, so it has 1 less 0 behind the decimal than the exponent. Or another way, and it's written here for number 3, it says when changing a number from exponent form to a decimal, so exponent form to a decimal, we're going to start with the number 1.0. So you're going to start with 1.0, and you're going to move the decimal the number of times the exponent says. So we're going to move that decimal 3 times to the left. Once, twice, 3 times, and you have to be really, really clear about which ones you have to add a 0 into. So I just have to add 2 zeros. And then I can always add the 0 before the decimal. Okay, so if I were to rewrite that nice and neat underneath, it would be 0.001. Okay, let's try the next one. So we have 1.0, or you could just write 1 point, it doesn't really matter. And then we're going to move it over 2 times to the left because our exponent says to the negative 2. We're making it a small decimal, and you only have to add 1 0. Again, that 2 is in the 2nd decimal place away from the decimal, or you could think there's 1 0 after the decimal. Okay? Go ahead and try the next 2 on your own and pause the video and then see if you get them right. All right, so the answers are shown here. So 0.00001, 4 zeros, 1 less than the exponent. The 1 is in the 5th place away from the decimal. And 0.0000001. So the 1 is in the 7th place away from the decimal. So what I want you to do now is go ahead and flip over the paper, and you're going to work on the back. You can use the front. Just make sure, as an example, just make sure that you are reading, for the first one, exponential form. So it needs to see the exponent. for the next 5 through 8, decimal and fraction form. Okay, so I need to see 2 answers, decimal form and fraction form. All right, good luck. Nice job.